Hey, so I just finished Split Fiction like a few days ago, and I was really curious as to how these guys have done it, on how they managed to get these two worlds um, rendered together at the same time with two drastically different art styles and two different types of interactions. Well, here's how I think they did it. There's three different ways I believe to do this. The first one, which logically sounds the most simple, is that what you would do is you would place world one in here, or say this corner of the world, and you would place world two right here, right? And you would in this case you would have to link the two assets with each other. What I mean by that is that the crate here and the mushroom right here, they need to be linked to each other in such a way that when this crate is updating its position or rotation or any translation or transformation, the mushroom should have the same transformation or translation applied onto it, right? This is how each asset that needs to be interacted with needs to be linked with each other. Also, another problem that comes in this sort of a setup would be the player character. So this is player one and this is player two. And what would actually be a problem is that player one is also rendered for player two, which means player one also needs to be part of this world and player two also needs to be part of this world. And that means that any movements that I make, so I'm walking or my partner right here is walking towards me, need to be replicated on this character as well, or on this character in this case, right? There's no problem as such because you could in theory link that. um, the the minor problem you would face is a delay, which is what I think. Again, I'm not pretty sure because I haven't actually done any of this practically, right? In linking assets and updating the position via links, I would assume that there would be a minor delay, which would be actually very noticeable over even a small amount of um, distance across the world. So, for example, if I'm in a city and my partner is playing from a different city, I would still be noticing a very significant delay in updating the position of those assets. Another This is one of the reasons why I think they did not go through with this kind of a setup. The second setup, which also is kind of simple and is very doable, is can be done using custom stencil settings. I believe you can find that in your project settings somewhere. Custom depth, maybe is that what it's called? Yeah, there you go. So under your project settings in rendering, you would want to enable any custom depth stencil pass, which basically enables your project to use the stencil buffer. Um, for people who do not know what a stencil buffer is and just want a small what do you call it? An overview. Think of think of a stencil buffer in such a way that you can assign. Let me see. It's right here. Yeah, you can assign a numbered value to an object. For example, this object or this object right here, this ceiling object. I can search for custom. I would say render custom depth pass, and I would say a value of 1, right? And once I have done this setup, what I would then need to do is go into the material and firstly make it a masked material and a post-process material because it does not work on surfaces. Um, wait, and you would want to get a bit mask. This is a function that you will get with Unreal, and you would want to get a single constant, float one or whatever, constant one. You would want to apply this value, whatever value you have put in as the custom depth stencil value. So I would put a 2 here, and I would assign a 2 here. Then I would search for the same texture. I'm gonna get the custom depth pass, divide it by 255, so I get 256 different custom stencil values. Mask it because I just want a single channel of it, and then put this mask in the bit mask. And now you're gonna say it cannot be used in opaque materials, so then I'm gonna have to make my material translucent or masked, or translucent. Yeah, translucent looks, I guess. um Anyway, the reason why I think this would not work is because of the material setup requirements. And you will see no change here unless I actually change the value of the, oh, I can't interact with it, I guess. Where's the ceiling? Yeah, unless I change the value, say 1, or I'm actually gonna have to set up in my camera that, okay, only render with 1 or 2. But yeah, basically what that means, in again coming back to, I digress, coming back to the topic, um, what it means is that in terms of the game, in terms of split fiction, um, only the materials with custom depth value 1 are rendered here, and only the materials with custom depth value 2 are rendered here. Now this is just for the visual materials, right? And that would create a problem of interaction. For example, if you see, I can interact with this crate, but my partner in her world, it's a mushroom, so she can't grab it, even though even if she's standing right in front of it. I can grab it, I can move it. She can stand on it and she can jump because it's a bouncy mushroom for her. And once I stand on it, also this is a bug, I'm going to talk about it later, but once I stand on it, you see, I don't jump because it's in my world, it's a crate. um, so doing the setup with a custom depth stencil pass would actually create a bit of an issue for you, which relate to the interactions, and that can actually be um, solved using data layers in um, in your world value. Sorry, not world partition. Yeah. So you'll have to partition your world in 2 different sections. You would have to assign each section a data layer, a sci-fi data layer, um, a fantasy data layer. You'd have to then put your sci-fi assets, interactions, and all those components in the sci-fi data layers. And similarly, you would want to put all your fantasy interactions, fantasy assets in your fantasy data layers. Because even the most efficient way to do it, or the most the way that uses the least amount of power or math or GPU calculation or whatever you want to call it, right, um, would be actually using vector math. And the way you would do that is you would just need to actually simple material functions. One of them, a cross product 2D. What this is going to do essentially is it is taking ax, multiplying it by by, subtracting that, actually this needs to be in a bracket, and subtracting that with bx multiplied by ay, right? And you can see that here, this is ax multiplied by by, and then that is sorry, this is ax multiplied by by, because the y component of the b is actually put in here, and this is bx multiplied by ay, and that is just being subtracted with one another, and that's what you get as an output. That's basically the cross product 2D function. And after this, you'd want a masking function. What this masking function is, in theory, going to do is, I'm going to take this sphere as an example right here. Um, Say that my camera is placed right here. This I'm going to call a pole 1. I'm going to call this pole 2, and I'm going to call this my object, right? And what that function that I just showed you is essentially doing is it's checking if this object is in between pole 1 and pole 2, right? And if it is in between pole 1, it's returning a value of 1. and if it's not in between pole 1 and pole 2, it's returning a value of 0. And that's what it's doing. This input vector A is my pole 1, absolute world position is my object, input vector B is my pole 2. I'm doing some cross product to get the distance between these vectors, and just checking, okay, if this asset exists, this object exists between these two poles, then it's returning me a value of 1 or it's returning me a value of 0. I'm multiplying those two together because I'm getting two different um, um, outputs. What I mean by that is I'm getting an output of all this vector A, B, and C. So I'm getting an output of A and B, and I'm getting an output of B and C. So I need to add them together, and I could actually use add as well, but I've decided to multiply them together because I just want both of these, right? And I find that works better. And how that actually looks in game, I'm gonna grab this sphere out of the way for now, just to show you how it looks, right? I'm gonna start simulating this level, and now you can see it's a chair, right? But as I move around, the asset swaps, and we have a window, a table, and this piece of glass or the showpiece or whatever. And if I show you if the like if I go inside these poles, you'll see how it actually works. It can look quite trippy and weird, but yeah, this is basically just how it looks. And as long as um just to recap here, as long as my is chair object is between my pole 1 and pole 2, it's rendered. But the ray that is hitting here, it finds that, okay, this is not between pole 1 and pole 2, so it does not render it. And then it again, the window renders, because for the window it's checking between pole 3 and pole 1, or 1, yeah, and so on, right? And which is why the window is rendered. Now this again is the most efficient way to do this. Again, you will need the help of data layers in order to get your interactions in line. And the reason why I think this is the case is coming back to that bug that I told you I was going to talk about. So you see how for some reason, while I was moving this crate, it decided to start floating, and you'll see it starts floating in here too. But I agree, it's very difficult to notice. So it starts floating now, and this piece is the mushroom has also started to float, just in case you guys haven't noticed that. I'll show you. There should be a single frame somewhere around here. Yeah, there you go. So the mushroom is now also, oh my god, how do I go back? I need to enable the frame controls in VLC. Yeah, so the mushroom is also now floating on top of this piece of concrete or whatever, which is not supposed to do. But yeah, so this is one of the reasons why I think they went with this route. And again, interactions are handled with data layers. Another example, which I found, by the way, to be very cool, is that there's no water on my side of the screen, or in my world. I'm playing Mio, but there's water on my partner's side of the world, and she can swim, but I can't, right? And I'm pretty sure, I didn't test this, but I'm pretty sure if I jump, I'm gonna go straight down and die. And also another thing, so the interaction that I showed you guys here is actually in world space, because my pillars are actually placed in the world. On their end, I believe it's in screen space. What that means is that the pole 1 is always on the left end of the screen, pole 2 is always in the middle of the screen, and pole 3 is always on the right end of the screen. Another reason why I think this is the way they went is because of their camera tech. I believe they've got a camera actor component set up in such a way that they're able to customize how much percentage of the screen it's taking up at a time. You would have noticed in any boss fights, when a player dies, there you go. When a player dies, the camera one gets smaller, um, you see, and this player two gets a bigger screen just so that they can focus on what they're doing. And as soon as I will respawn or player one respawns, the cameras are back together, right? So I believe they've got a system which allows them to customize how much percentage of um, each camera is taking up the screen, and where those pixels or that camera is focusing on, or where it's rendering, right? I shouldn't have closed that. Yeah, so just to test my theories once again, I actually did a test with this sphere, just to show you guys how I set it up. I'm not going to do this custom stencil anymore. I basically made a blueprint, right? Blueprint class. I put in two spheres inside, two static meshes, two spheres. I called one Zoe, I called one Mio, because why not? Um, they don't have any special materials, nothing else. The only thing to note here is that once you create a static mesh, a variable will also get created by the same name as your static mesh. The type will also be a static mesh. And we want that, so that's a good thing, right? And then what I've done is I went into I created a new material. I'm going to delete these because I don't need these anymore. Right, I created a new material. I called it split. And inside that material, I'm just assigning a color value which I can customize because it's a parameter. And I have two borders, or in world space I would call them poles, but since they're supposed to be on screen space, I'm going to call them borders, right? And I'm using my masking function to input border one and border two, and that's basically it. To my system just now, I would need to specify what border one and border two are, right? And ignore this part because this is supposed to be for the chair, table, and the showpiece that I just showed you guys. But the way you would do that is just create a material instance of your material that you need, set a vector value, and set the color. You could also make a color if you want, with RGBA values, and assign that in here. I just needed to get this done quickly, so you decided to use a linear red color. Um, and this is the parameter that I want to assign it to. The parameter being um, this this parameter name. So this parameter name I'm going to write here. This dynamic material instance, this is the target for this. So for this instance, for the parameter color, I'm setting a color value of red. Then I'm doing the same thing for the border one, and I'm setting the pole 4. Pole 4, I believe, is maybe this one or this one. So this is pole 4. The way I got its reference into the level blueprint is just by dragging it here, and then I got its root components, get world location. So just do this world location static mesh component, or you could do a root component and or not set world location. I wanted to get world location. uh my bad. How do I get this? Get world location. Yeah, there you go. This is how you get it. For pole 4, right? And you could use root component, and that's fine, but it's not rooted to anything. So even static mesh component would work. You would then convert this vector value into a linear color structure value, assign it to that. It's weird, but it works. Similarly, you would assign border 2, which would be pole 3, which is right here. And then I would just assign this material to split test, which is my blueprint in this world. I'm going to grab it in my level blueprint, and I'm going to say, okay, because I want to assign it to Mio, I'm going to get static mesh Mio, and I just assign that as a target here, right? And it's now going to set this red material to Mio, which would only render between border 2, border 1. And then I'm doing the same thing for um, for the green, for a green material, between pole 1 and pole 2, which are supposed to be these two, I think. Yeah, pole 1 and pole 2. And yeah, this basically it. And I'm setting my color as green. I'm setting my poles correctly here. Parameter names are the same because it's the same material instance. I don't need to change the material at all. And I'm just gonna, instead of assigning to Mio, I'm now gonna assign this to Zoe. And what that does, I could assign it to Mio, um, and that would still be completely fine. But because I just wanted to showcase how you could have two different assets placed in the same space, or same 3D, same 3D space, how that works, right? So maybe a better way to do that would have been to actually make it a cube. Let's go for a cylinder. Okay, let's see how this works out, right? And you see the cylinder. Now okay, I don't want to play, I want to simulate actually. So once I start simulating, you see how I just have a cylinder, and as I go around, the cylinder disappears, and now I have a sphere, which is red, and my cylinder is gonna be green. Yep. And you could do this in world space too by just attaching these two poles directly to your camera actor, or three poles to your camera actor, which one always stays in the center, the second one to the right, and the first one to the left. But I think it would be better to make a camera component for a game like this, to make a camera component that just that you can basically just input. Okay, if you want to render the sci-fi world or the fantasy world or any other world, because well, you do get more. Oh, another piece I want to talk about after this is the section we just skipped over. So you see how there's multiple worlds shown at once here. So this is the first fantasy, then there's something sci-fi, and then it swaps to a third world, which is leaves floating on and then the fourth one, which is piranhas, and you get a bunch more later on in the level. Yeah, like so, right? And I think this would have been like the best way to do that, because you would need a camera setup. Talking about the camera setup, the section that I just skipped over, um, yeah. So remember how I was talking about how I think they have a camera tech which allows them to define how much percentage of the screen it's taking up. So I think if they're just if you, with that camera tech, if you would just force each camera to always hold up 50% of the screen, you would end up with something like this, right? Because no matter what, our player characters cannot cross over into the other world. You can see my partner trying to jump into my world, but the border is always separating us. You could see some assets rendered right here and there. Like you see the my partner's characters, arms and feet were, or like limbs were rendered there, or even the head, hair, and so on. Just a tiny bit that's clipping. Yeah, you can even notice that right here. You see when we cross over, because she goes right and I go left, we both bleed into each other's worlds, but the border then quickly decides to adjust itself, because I'm supposed to be in sci-fi and she's supposed to be in fantasy. And I yeah, so vector math, data layers, camera tech, um, very weird looking, very nice four-dimensional looking thing, but not as complicated as one would think. Yeah, even here you can see as she crosses over my character standing there, the camera just decides to automatically just adjust itself to always hold up 50% of the screen. And another very fascinating section was this one. So once again, this my theory of rendering with vector math supports this level as well, where you could just walk into the other character's level. So for example, right here, right, these are the same world but rendered from two different cameras, and we can't cross over, right? Because we're both rendered twice. We both exist in each other's world as well, because we have full camera control, right? But in this level, in the second one, Our camera control is taken from us. Camera is fixed. So my partner is always on the right side of the screen. Her world is on the right. My world is always to the left of the screen. And now because the camera is fixed and we have no control, we can now cross over. And that is also a different logic to what was being applied before. Um, and I love the fact about um, that particular fact about the last level in itself, because every subsection of this level, there's a different kind of logic applied to the gameplay, where full camera control, just like how you were going through the entire game previously, now cameras are locked. And oh, one of my favorite sections is this part. And again, because now I can interact with the water, because those data layers are now enabled for me, I can also cross over to the left to see what would happen if I fall, and dash back and just start swimming immediately. And you can see some water splashes actually drop right here, right here in my world, which basically supports that it's done being done, like it's done using this, because this is just a VFX, and you can rarely stop VFX from bleeding into um, um, like you could actually do the VFX in data layers as well. Um, but yeah, I guess somebody overlooked this part of it. It does look cool though. And then in the next section, of course, you can't cross over. The screen is always 50%. The section after that I just spoke about is that where they're using their a single camera but different world technique to change um, the actual art as well as the hitboxes, so that these hitboxes would kill you. And then the final section, this one seems pretty simple actually. It's not too complex. The one thing I love about this section is that the weird effect that Zoe has on the screen to track where she's walking, and I love this. Um, and probably this is done probably very similarly, where okay, one camera is rendering Neo and her world, and Zoe is, and that is being projected onto this screen that Zoe is standing on. And only where Zoe stomps, if Zoe stomps anywhere else, this won't work. But if she stomps right here, because there's a probably like a trigger box or something here which detects when Zoe is stomping, and only then that door would break. Or similarly, right here, which would track when this crate would move up. Again, not this is not as complicated as the previous ones. At least it doesn't look complicated if it is. Um, and this is just my guess. So yeah, these were just a bunch of my guesses. And for the last section, yeah, tilting. So this also basically what you would do here is of course you want to tilt the camera um, to make the player think that the entire world is being rotated or tilted. But you could achieve this exact same thing very simply. Just rotate the camera, um, and probably when rotating the camera, you would also apply gravity in another axis. So, for example, when I'm rotating it left, the camera rotates left, and gravity is applied, say maybe 10% or like whatever value you want to give it to the left as well. So all of these physics based interactables also move according to which side the gravity is applied to. And yeah, I think that's pretty much it. I think the coolest tech here, I believe, that they've done is oh yeah, the final cutscene. This is done. I believe this can be done very similarly to what Ratchet and Clank Rift Apart did. Um, but yeah, getting those assets to be loaded and those areas of the world to be loaded, you would have to make them very modular. This was pretty fucking cool. And yeah, I think what happens at the end when they both smash? Nothing. Cool. I mean, it does go white, and nothing happens in terms of the world, you being able to look at both the worlds, right? It's just pure white. Um, yeah, so I think one of the coolest techs in this entire level, I find this to be one of them, where you can just cross over where the camera is stationary or partially stationary. Um, Purely because you could make such a good explanation of the fourth dimension using this technique, or a fourth physical dimension using this technique, because this is just the example of 2D being able to cross over into 3D, but taking up a higher level, a higher dimension, so from 3D to 4D. And um, and the other one that I find to be really cool is this one, where I'm pretty sure they'd have had to do a bunch of camera camera setup, like a huge camera setup. Not just huge, but maybe to have like a custom component which only allows not only but a custom component which allows um, the developers to customize what percentage of the screen a camera is taking. I've been rambling for too long. That's it. Bye bye.